So my project was the energy-saving light bulb. So I was doing this because annually, like, people waste a lot of money on like electricity, and in the U.S., numbers have even reached billions of dollars, and a lot of money is wasted by like just leaving your lights on, which is a very simple thing, but it actually costs a lot. So also, like, it's an environmentally, it's like dangerous for the environment because electricity is mostly made from coal, and like that pollutes the environment. So studies have shown that in the U.S. alone, they produce like 14.4 million tons of carbon dioxide every year, which is really bad for the environment. So my goal of my project was to save energy by using the sun as a light source instead of like artificial light. So my project, it's like it must be able to like adjust the amount of light coming out of the light bulb according to the amount of light that's coming from outside. Like the sun, you're like measuring the sunlight. So by doing this, I will never waste like extra electricity when I don't need it. So my solution, how my solution works is first a photoresistor senses the amount of light coming from outside, and then after it adjusts the light bulb if it's bright outside, it like dims, and then when it's like not that bright outside, it the light bulb brightens up. And all of this is controlled by a Arduino board, which is like sort of like a computer chip. Okay, so this is like a diagram of how it works. So first, as I said, it like senses the amount of light, and then that gives the information to the Arduino board, and then so then the Arduino like processes it, and if the brightness is over 110 over 250 flux, then it like dims the light since there's a lot of sunlight coming, and then if the brightness is below 110 over 250 flux, it makes the light bulb brighter because it's dim outside. So this is my diagram. This is the relay to turn the light bulb on and off, and there's the photoresistor. It's sort of small, but like it's a sensor, and then it's the 5-watt light bulb that's like the light source. So this is my process diagram. First, the input, so it's the photoresistor sensing the amount of light coming from outside. Then it goes to processing, which is the computer will find the amount of light to output out of the light bulb according to the amount of light, according to the input. And then the output is the how bright the light bulb is. So these are my materials and the cost. You can see it's relatively cheap. I tried to keep the price down as much as possible. Okay, so this is my comparison. So my project is unique because it changes the amount of light that's coming out of the light bulb, while other products either only turn on or off the light bulb or change the color of the light bulb. In summary, my project is the best it can be because it senses the amount of light that's coming from outside, and then it processes it and then outputs according to the input. So my future goal is make the project smaller. I might be able to do this by sending a signal between the photoresistor and the light bulb. This will make it so that it's easier to it's smaller and it's less noticeable when it's attached to a window. And then there's this is my bibliography. It's my research, and yeah, that's it.
Great job, Samuel. Samuel, how old are you?
10.
And what grade are you in?
5th grade.
5th grade, wow. You're another round of applause for that.
Do I click to the...
Okay, so now we're going to have 4 minutes of questions from the judges that starts right now.
So, does your project work right now?
Well, no, not right now, but I showed how it worked on the previous slide, so yeah.
What other applications might you be able to apply this to, maybe other than light bulbs?
Like the shades, for example, it could go down or something when it's bright outside if you want it to be dim in your house. I don't know.
It's a good idea, yeah.
Yeah, just overall, I think that was a really amazing presentation, and I was really blown away by how you were able to elucidate the problem and the uniqueness. I think just one question for me is, where do you put the sensor? Can it be anywhere? Can it be in a room, or does it have to be attached to a windowsill?
It's attached to the windowsill because it's easier to sense the light. When it's attached to a wall, it's harder because it's less the light isn't, it's also sensing the amount of light in the room, not coming from outside. So
very impressive. If you are given more time and more help, what would you like to improve on your current invention?
Make the invention smaller. Yeah, since my invention is pretty large right now, so it's very noticeable, and you don't really want a giant thing on your windowsill. So yeah, I want it to make it smaller. Yeah.
Sam, like the other judges, I'm very impressed with, in particular, your articulation of the problem and your articulation of your solution. One question that I have to think about is amount of light that you have in a room is a very personal preference. Some people want a lot of light, some people want less light. So the one question I have to think about is there a way that you can work personal preference into the design of your invention, knowing that right now it appears it's one cutoff for at this particular level of lightness it either goes lighter or dimmer. Is there a role that personal preference could play in how the invention is implemented?
I was going to add that if I also had more time. I could the person could input this set of brightness they want in the room, say 50% light or something, and then yeah, that might work.
I think one last thing I wanted to add as well is that you need to make sure that the light sensor isn't pointing towards the light bulb itself, because otherwise you would be accounting for that light and thinking that's the ambient light, when in reality that's your artificial light that you're creating. But yeah. All right, round of applause to Samuel once more.